Hi, I'm going to talk about visualizing queries in the browser. Yeah, let's go. So just get to know you. I am Noam. I am a senior front-end engineer. I live in Berlin, and I really like chocolate ice cream. And today I want to talk about visualizing um, uh, CQL queries in the browser. So at Up42, we build a platform to so satellite providers can sell satellite data to customers, and we want to make exploring the geospatial data easier for our customers, and we build this UI because it turns out much easier than just doing some arbitrary stuff on the SDK. Um, but um, when we start to build this, I checked and to see how other people have done this before, because this should be something solved. This is a form on the web. It's not very difficult. And yeah, some other people have solved this. This is a planetary computer form, also looks very common, the stack browser. But there was no JavaScript library to convert the form data into something that can go to the server. So I had to make one. So I want to introduce the CQL2 filter parser library. It's a library on NPM. Uh, it's a unified way to parse SQL text and JSON encoding. It runs on Node, on JavaScript, all other hosts. And it is extendable, and I will talk about it. At the bottom, this is a playground that shows what can be done with the library. This is not like, okay. So CQL2 filters. Um, CQL2 filters are OGC standard to query stack databases. Stack databases is also an OGC standard. It's a way to organize geospatial data. There is the stack catalog, which contains all the data items, and the stack items are the atomic unit for all the stuff. Like geospatial items are usually spatial or temporal or both, and stack items are the atomic unit. And when you query using CQL the stack catalog, you get a list of stack items. So I said earlier two encodings. CQL2 is a language that has two dialects, let's call it. One of them is text. CT equals Mostar is an example. Very terse, very human readable. The second one is CQL2 JSON, which is, let's say, more oriented towards computers. Sorry. It's a little bit harder for people to read, but it's, I would say, easier for computers. Other than that, there is no flow controls or loops. This is an expression language only. It doesn't have statements, so you can't declare a new variable. You can use variable, and I will talk about it. There is no loops or recursion and stuff like that. So it's very easy query language. So why two encodings? So first of all, I said earlier, the audience, people versus computer. Um, some computers can read SQL to text. There are some services that support this, but it's not super common. And usually, it's maybe easier to send SQL text as a GET request and SQL to JSON as POST request. So that's something that maybe should be aware of. There are other languages that support two dialects. If I remember correctly, OpenSearch support it, and Prometheus also has something similar. This is because query language that need to go over the network, you can choose how you want to send the thing. Okay, and the building blocks. So for CQL2, there are literals, which are the strings and numbers and rest of the things, which are like the primitive data things. Properties are variables. Operators are like equal, logical operators, comparison operators, arithmetic, stuff like that. And they are combined using binary expressions or functions. So the equals, CT equals master is a binary expression. 1 plus 2 is a binary expression. Other than that, the language also supports spatial expressions and temporal, like time, percent, and date. Okay, so how do we actually use that? Under the hood, the library has has two separate parser, one for text, one for JSON. But you can use either parser if you know what you have, what the input you have. But if you just want to parse something, there is a very simple parse function which will try to guess what we're showing it. If it's a text, if it's JavaScript string, then it will try to parse it as text. In the end, the data structure that is going to end up is an expression tree, which represent all the components, all the nodes. Finally, some code. So parse an expression, and you will get, first of all, which encoding is there, and then the expression. The expression data structure has two built-in methods, to text and to JSON. So if you want to use CQL2 and display to your user for some reason the form in how it looks like as a text, or if you want to ask ChatGPT, please build me some query, and you want to move it from text to JSON, the library covers that out of the box. It's super simple. So standing the library. It is a library, and it can support all the use cases in the world. And that's where visitor design pattern comes in. It's one of the design patterns in the design pattern book. And it's used to separate the algorithm from the data structure that it applies to. So in this case, we want to build a UI on top of our data structure. So the visitor pattern is something that can help us. So each node has a corresponding visit function. Each node is represented by a class, and the class should have some visit function implemented. So for literal, again, strings, number, booleans, we have the visit literal expression. Properties has visit property expression, etc. I will use these four to demonstrate what we can do to build a very simple HTML builder. So we have an object, JavaScript object, very basic one. It has inside four visit functions. Each of these will receive as an argument an expression and return an HTML element. Then we will parse whatever expression we want, and we can put it into our HTML document. Try to keep this as simple as possible and readable. And let's see how the actual implementation looks like. So I have abstracted away how to create the elements themselves because it's very verbose. What I do want to focus is the visit binary expression. So this binary expression receives as the argument a binary expression, and it has a left, an operator, and the right. These left operator and right are expressions themselves, so they can accept the visitor. So if the left is an operator again, or either if the left is binary expression, it will use the visitor to recursively build our form. And that is all you need in order to build some very basic form. So there is an example in the repository linked later that shows how to. This is basically neat. Basically, two, three binary expressions where ct equals master and the talk duration is over 20 minutes. And that's it. So this is the library. Again, it's a unified way to work with CQL text and JSON. It is JavaScript built using TypeScript that runs on all the hosts. And there is a playground, which I can show later. Yeah, I'm way
Is
before
it all?
time. Yeah, I'm way before time.
Then a big applause. We can take questions. We gotta speak to the microphone. Do you have any? If not, we can chat about this. I
Yeah,
don't know.
I can also show it like relatively. Let's.
Yeah, we still have like
I will hope it
7 minutes.
works.
On the computer, we can show.
With
Are you
more.
interested?
Yeah, it's so yeah. So one example. Let's make it a little bit larger. Is it visible? Yeah. Okay. So let's say we have some very simple. Okay, unfamiliar keyboard. New experiences.
Uh, in the meantime, I can ask how many people actually aware CQL2 filters? How many people heard about CQL2 filters before? Before then, you're familiar.
Okay. And how many
Also,
people are using it? Yeah.
okay, yeah.
Okay, we
Please,
use
please
them
go.
very extensively on our platform. So in this case, we have the builder and the editor are combined together. So if I try to change one side, we'll go to the other side, and multiple examples if you want to explore this. Um, this is much more verbose approach. Yeah, that's it. Thank you.